Yesterday we talking about Kmap, right? Okay, okay. So let's practice. Uh, if the function is a and b plus c and d prime, could you fill logic 1 output in this Kmap? Can you? Okay, tell me. At first, for this term, this product term, A and B will be 1 when A is 1 and B is 1, right? Then which cell is 1, B is 1? This, this, right? Okay? Yes? Okay? The meaning A, B is 1, 1, right? At here. Okay? Good. Okay, now, or C, D prime. This term will be 1 when C is 1, D is 0. Which cell? C is 1, D is 0. 1, 1, 1, right? Okay? So, if you have a function equation, you can write down 1 in Kmap. Okay? And for the empty cell, actually it gives 0 output. Okay? Okay? Everyone okay? Understand? Okay? So, if you have a Kmap, for example, 1, 1, 1, 1, 1, 1 at here, and you want to know the function, what should you do? Just select, right? Group in 1, 2, 4, right? Pattern. For example, this one. The product term of this group is, yes, A and B, right? Because A is 1, B is 1 for every cell, and CD unspecified, right? It cannot be both 0 or 1, okay? That means this group, the value not depend on value of C and D, depend on only A and B. Understand the meaning? Okay. And how about this one? Can I group this one? Yes, but it's better if I select all of these 4 cells, right? Okay? And this 4 cell is C and D prime. So your function is A and B plus C and D prime. Okay? Understand? Everyone understand? Okay. So when you got the equation, you can check by replace 1 in Kmap again if you want to check. Okay, your function again want to be 1. Your output of the function want to be 1 when the input is in this cell. So when you select the cell, when you group it, the cell that is selected will give logic 1 output. For example, listen carefully. This cell, the input A, B, C, D that's corresponding to this cell is 1, 1, 0, 1, right? So when you apply A, B, C, D with 1, 1, 0, 1, 1, 1, 0, 1, it will give the result 1, right? Okay. The cell that you select will give logic 1 output. How about this cell? For example, this cell. The input of this cell is 0, 1, 0, 1, right? Okay. If you apply A, B, C, D with 0, 1, 0, 1, how about the result? It becomes 0, right? So, the cell that you not select will give 0 output. This point is very important. Okay? The cell that you group or select to make the function will give logic 1 output. The cell that you not select, its input will give 0 output. Okay? So, if you want, again, the function that give logic 1 output in this cell, this cell, this cell, and in this cell. So, you must select out of this logic 1 output, right? Okay? You must select all. If not, for example, if you not select this cell, the function that you obtain by select only these 3 groups will give 1, 1, 1, 1, 1, 1 at here, but not at here. When you apply 1, 0, 1, 0, the result will be 0 at here for the equation that you obtain by using only these 3 groups. Okay? Understand? So the most important is you must select all of these 1 cell. Okay? Only 1 cell must select all. And be careful, do not select something like this. If you select this one, your result will give logic 1 output at here, right? Right? But the problem want 0 at here. Okay? So be careful. Okay, if you understand the next one, okay, if you understand this point, it's easy for you. Atwin, where are you? Absent? Okay. Absent. Go in. Okay, let's try this example. It's easy, this one. How about this? That you write down the function. How I select this one, right? A prime and B prime. How about this group? This group A, 1 here, right? Same one, right? So A and C, right? Okay. For B, different, right? D dot different. Then it's not appear in this term. So your function is this term plus this term. A prime, B prime plus A and C. Okay? Good. Next. Already? Katapat? Katanat? Sorry. Katanat? Absent? Okay, absent. Komchan. How about this one? How about this one? A prime. That's all right? Okay, how about this? D, yes. How about this? How to select? 4, 4 or 8? Two group of 4 or one group of 8 cell? How to group? 4, 4 or 8? Two group of 4 cell or one group of 8 cell? Which one? 8. Okay. Tell me the product term of this 8. Why? This cell is 0, right? This row is 1, right? B? No. Okay, B prime. Okay? Every cell, the value of B is the same. Okay? 0. 0, right? Then B prime. Okay? Okay, please, okay. Next. Whose turn? Kanop, where are you? Okay. Kanop, how are this? Let us try to find the function. How to group? Okay, the main point you must select all of these logic 1 output, right? Right? Must select all to complete the function. So how to select? Select this one? Yes, okay? Okay? It's okay, but not okay for me. For good design, it must have smaller term, right? For smaller term, you should select bigger, okay? And bigger if it's possible. How many cells should select? 2? These two cells? No. You should select these 4 cells. It's better, right? Don't forget A, B, 0, 0, 1, 0. Different one bit, right? So you can group these and these together. Okay, tell me the product term. Product term in the term of variable A, B, C, D. How about A? Here A is 0, here A is 1, right? So, no A in the product term, right? How about B? Cannot. This cell, B0, right? This cell, B0, right? So, how to write? Yes, B prime. What else? B prime and what? Yes, C prime. How about D? How about D? No D, yes. Okay? Okay. Let's continue. You must select all of logic 1, right? It's not finished now. How to select? How about this one? Only one cell? Okay? No. It's not good enough. You must select the cell with this one, right? Okay? Okay? Okay, how about the product term? this cell A 0, right? Same. This cell B 0, right? The same. This cell C is 0 at here, 1 at here. So C not appear, D 0, 0. So A prime and B prime and D prime. Good. How about this? How about this? Only one? Only one cell? Only one cell? Okay, this one, right? So tell me the product term. This cell A is 1, this cell B is 1, this cell A prime, B prime. You read? Why? A and B and D prime. Okay? Cannot okay? Okay? Easy, right? Yes. So, okay, that's all. Okay. This one I just show Kmap for 4 input variable, right? Right? 4 input variable. So there are 16. How about 5 input variable? This one, 5. 16 and 16, 32. What does it mean? Cannot, for example, tell me the input for this cell. A, B, C, D, E is input value. Is AB is 1, 1, right? CD is 1, 1, right? E is 0, okay? So it's 1, 1, 1, 1, 0. How about this cell? Yes, 1, 1, 1, 1, 1, right? Different 1 bit, okay? Different 1 bit. That means you can group this and this together, okay? Then it become what? When you group together, A and B and C and D, right? Okay? Okay? Good. And how about this? 6 input variable. No, how about this? The input that corresponding to this cell A, B, C, D, F is 1, 1, 1, 1, 0, 0, right? How about this one? 1, 1, 1, 1, 0, 1. How about this? 1, 1, 1, 1, 1, 1, 1, 0. How about this? The value of A, B, C, D, F is, yes, 1, 1, 1, 1, 1, right? So, cannot, if my Kmap is something like this, it's for you. How to group? How to group? Okay, let's start for you first. It is good enough if I select only this 4 cell. No, right? I should select this one also, right? Okay. So tell me the product term. What? Why A, B? Yes, C and D and what? And yes, and F prime. Very good. Okay, because F is zero, F zero, right? Okay, every cell F is zero, then F prime also. Okay, how about this one? Let's change color. I select these two cells. Like good enough? No. What should I do? How many cells? Four. You mean this one and this one? Yes? No. You can group this one also together. Okay? So these 8 cells, the product term of this 8 cell is C and D. That's all. That's all. No. You can check. How about A? Oh, A different. Okay, A disappear. How about B? Oh, B is one, right? Right? And B. Okay? Okay? Okay. How about this? Last one. This term, you must select all of one, right? You should select these two cells also. It is good enough if I select only these two cells. No, you can select these four. Okay? Okay? So tell me the product term of this four cell. B and D, that's all. And 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 F, that's all. And yes, and D prime. Okay? Okay? Okay. That's all. Easy, right? You just find, okay, the input variable, right? Is single value or not, right? If it's 0 and 1, then it will appear. If you have only single value 1 also, then it will appear, okay, in the product term. Okay, that's all. So now you become expert in Kmap right now. Okay. If you're not clear, you can ask Mr. Kano. Okay. The Kano can give you some advice. Chanakan. Okay, your turn. Okay, let's continue. Okay. Okay. Now you know how to use Kmap. Okay. This just example as the previous one. Namely, the previous one we for this problem. This one. Sorry. The example. Okay, this one. Did you remember? For this one? Okay. For this example, I use min term for the input that give logic 1 output, right? Sum together. Namely, is chemical sum. If you implement the circuit based on this equation, you need a lot of logic gate, right? Okay, by the way, if I use Kmap to reduce number of logic gate, the result will be something like this. Same condition of the problem. So I fill logic 1 output in Kmap. Okay, can you group to find out the function? Of course, you must select all logic 1 output, right? Okay, tell me the number of cells. You can refer 1, 5, something like this. Okay, 1, 5, 3, 7. Tell me the product term of this group. N, 0, and N 3 prime. That's all right. Okay, what else? You must select all of logic 1, right? 5 and 13. Okay. Okay, this group is N2, N3 different, right? N2 and N1 prime and N0. Good. Okay. How about this one? 11 and 3. So the product term is N2 prime and N1 and N0. Okay. And the last one. Okay. How about this? 3 and 2. Okay. Then it become N3 prime, N2 prime, and N1. Okay. And you sum of this product term, you will get minimal sum of the function. Okay, the result is called minimal sum. Namely, it's form of sum of product with minimal term. Okay, minimal term, minimal variable. So you become expert now. Okay, next one. Chanson. Okay, Chanson. From this, for the result, you can write down or draw the circuit diagram for the equation. After that, you may test uh, the circuit by applying the value of N3, N2, N1, N0. For example, this one is called timing diagram. The chart is called timing diagram. Okay, this axis is time. Okay, and the vertical axis is logic, high and low. Right? Logic 0, logic 1. For example, this duration N3 through 1, 0 is 0, 0, 0, 0. Okay? If I apply 0, 0, 0, 0 into the circuit or into this equation, the result will be what? 0. Okay? Okay, now, if I apply 1, 1, 0, 1, how about the output? N3, N2, N10 is 1101. Where? 1101, right? So output is 1. Okay? Everyone okay? Understand? The timing diagram, right? Okay. Okay, good. If you understand, then you can do homework or exam. Okay, next. The next topic, there's so many details. I will tell you by conclusion, okay? Some technical term that you should know. The first one, minimal sum. Minimal sum means it is right in sum of product, okay, form with minimal term and minimal variable. That's all. Namely, the result that you get by using Kmap is minimal sum. If you select, okay, number of group as few as possible and each group as big as possible, the result will be minimal sum. And the next term is imply, imply and implicant. Okay. For imply, for example, do you know imply? P imply Q something like this. If P2, then Q2. Okay? It's like if then. Okay? Imply. In this case, for example, if product term, this term become true, then this product term, then function f will be true also. Namely, the input that make this product term become true. This the same input will give the same logical output for function f also. Okay, it's called imply. Okay, now the next word is prime implicant. Prime implicant. The definition is normal product term that imply f, such that if any variable is removed from P, then the resulting product term does not imply f. Which term? I forgot. Sorry. Chanson, understand? Understand the meaning of this? Understand? No. Okay. No, it's okay. If you understand by only first glance, that means you are so genius. Okay. It's quite mathematical language. So, what does it mean? For example, this schema. Okay, look carefully. If I select only this one is what? N3 prime and N2 prime and N1 prime and N0, right? Okay. If I remove, for this one, this term become 1 and this function become 1 also, right? Okay. Okay, based on this example. If I remove, for example, if I remove N2, then it becomes N3 prime and N1 and N0, right? That means it's cover these two cells. Okay? Okay? That means I can expand from one cell to two cells. Okay? If I remove again, remove what? N1, Okay, it's bigger and cover this 4 cell, right? Okay, and this 4 cell also can make the function f become 1. Uh, can I remove n0 or n3? Can I? If I remove n0, what happened? If I remove n0, what happened? What happened? It will cover this S here, right? But it's 0 H here, 0 H here, 0 H here, right? So it's not okay. Okay. If I remove n3, n3, it will cover 0 H here, H here. It's not okay. That means the maximum size that cover only one cell, okay, its product term is n3 prime and n0. Okay, you cannot remove furthermore input variable from this term. So this term is called prime independent. Okay, namely the product term that you get from Kmap by select biggest size. Okay, it's called prime independent. That's all. Okay, the meaning of prime independent. And one more word. Uh, one more word. For example, okay, let's find out this one first. Can you find all prime independent from this example? Can you? Yes. If I select only this one, okay? No. This one? No. Okay. This 4 cell? Yes. Okay. The product term of this 4 cell is prime independent, right? Then you can find the product term. For example, it is what? Y prime and X, right? What else? The product term of this also, right? Okay. What else? This one, right? What else? This. Okay. This 4 cell. That's all? No. Okay. This 4 cell also, right? Okay. So all of this is prime independent. If you create a function by use all prime independent sum together, the result is called complete sum. Okay? Use all prime independent. Okay, sum together. It's called complete sum. Okay. But if you need to minimize the size of the circuit, you need not to use all prime independent, right? For example, for this example, you use already this and this. That's enough, right? You need not to use this prime independent. Okay? If you use the smallest size of smaller number, okay, of group, so you will get minimal sum. If you use all, you will get complete sum. And one more word, essential prime independent. What is it? Look at this. Don't forget to create a function. You must select all of logic 1, right? You must use all one cell. This one, look at this one. This one cell covered by only this term, only this part become, right? So you must use this prime indicand or this product term, okay, to make the function. Then this term is called essential prime indicand. You must use it to complete the function. Okay. If not, you will not get the function as you want. And this cell is called distinguished one cell. That means the cell that covered by only this essential prime indicand. So from this example, how many distinguished one cell? How many? One. Only one? Two? Only two? Three, right? Three. Three distinguished one cell. Okay, this one, and this one. Okay? Okay, now you know some definition. So, and for this page, maybe nothing. Just show some example. Namely, for this example, it just show that when you select this, or this, you will get minimal sum, or if you select this, this, also you get minimal sum. Okay, to possibility, okay, to get minimal sum. And for this example, there is no essential prime indicand because there is no distinguished one cell. Every logic one output covered by two prime indicand. Example. Let's summarize. And okay, now go to the next one. Thanish, พล absent นภัสสร okay นภัสสร now I want to find out minimal product. The previous one I want to find minimal sum. That focus on logic 1 output. For minimal product, I should focus on logic 1 output or logic 0 output. Yes, 0. So from this one, this 0, the corresponding input is 0, 1, 0, right? 0, 1, 0, x, y, z. 0, 1, 0 is 1, okay? This 0, 0, 1, 1, x is 0, 1, 1. And this 0, 1, 0, 1, 1, 0, 1. Okay? So now I write only logic 0 output. The empty cell actually is 1, 1, 1, 1, right? But now I focus only 0. So I can write only 0. Look, if I select this one, could you tell me the product term? It will be 0 when x, y, z is 1, 0, 1. So x prime or y or z prime. Good. Okay. How about this? Okay, you can select both, right? And the sum term is what? X or y prime. Very good. Okay. And then you take these two terms and together, you will get the complete function. So the cell that you select, okay, to get this sum term, you keep the result 0, 0. Okay, and this term will be 0 at here. That means when you add together, you give the 0 at here, at here, and at here. That's all. Easy, right? Okay, easy. Yes, very easy. Okay, and next topic is don't care. You know don't care? Okay, next one. So, Hakwan, where are you? Okay, Hakwan, give some example. You know seven segment display. You don't know. You know LED. You know why? You know something like this. You know, for some display we have something like this. You know, for example, stop clock, or when you go to some elevator, okay, we show the floor something like this, right? If this LED turn on, it show one, right? If this LED on, this on, on, it show two. Okay, okay. If I want to show 0 to 9, 0 to 9, namely 0, 0, until 9, for example, okay. Then for the binary code, maybe 0, 0, 0, 0, 0 to 1, 0, 0, 1, right? Okay. If I want to decide the circuit, when I apply 4 bits of binary input, 0, 0, 0, 0, it shows 0 at here, okay? If I apply 2 is what? 0, 0, 1, 0, it shows number 2, right? Until 1, 0, 0, 0 must show 9, right? Okay? Okay? So when I use only 0, 0, 0 to 1, 0, 1. But for 4 bit, it can be 0, 0 to 1, 1, 1, 1, right? Right? But I use 0, 0 to, but I use 0, 0, 0, 0 to 1, 0, 0, 1. Okay? I use already this. If I apply, for example, if I apply 1, 0, 1, 0, how about the output? You don't know, right? Okay? Okay? But you don't care, right? Because you don't use it, right? Okay? Okay? So you don't care. So in this case, the output for the case of the input that you don't use it is called don't care. Namely, it may be 0. Okay? It's okay, right? It's possible to be 1, right? Sorry. To be 1, right? It don't care. It can be both 0 or 1. Okay? In the design, 0, 1 become what? Yes, it's D. Okay? Okay. These don't care. So, okay. It's called don't care set. Namely, for example, this example, this is on set. Okay? If you apply the value of the input 1, 2, 3, 5, or 7, it gives logic 1 output, right? Okay? If I apply something like this, it don't care. It maybe it can be 0 or 1. Okay. So if I apply 8 in this function, how will the output? 8 output is 1 or 0. Yes, it must be 0, right? Okay, because 8 is not in on set and 8 is not in don't care set. So it must be 0. Okay, how to decide if you have don't care? It's easy. Same method. It's very easy, right? So you just fill logic 1 output, follow this. 1, 2, 3, 5, 7. Okay? And don't care for 10 to 15. If you don't care, right? Your objective, you must select every logic 1 output, right? Okay? You must select all. But for don't care, you can select or not select. If you select, the final result will give logic 1 output. If you don't select, it will give 0 output. Okay? Understand? Yes, very good. So, please show me how to select. I want minimal sum. Minimal sum, namely minimal size of equation. Minimal term and minimal variable in each term. Of course, I must select all logic 1, right? Okay, let's start. Okay, 1, 5, 3. This one, right? 7. Could you tell me the product term? Let's start from N3. N3, 0, 0, right? So, N3, 10. How about N2? No, right? How about N1? No. How about N0? Yes, N0. Okay? How about this one? You must select all logic 1 output, right? Then you must select this one also. How to select? Only one cell? 10. This one and this one, these two cells? Is good enough? Okay, this 4 cell. Very good. Okay? So the result is N3. No. N2. Yeah. Then N2 prime and N1. Okay, that's all. Okay? Now you select all logic 1 output. Then you can stop the process. And the result is this term plus this term. That's all. Very good. Okay? Okay. So you get the result, something like this. Then you get the function. Okay, now. May I ask you more question? Hey. May I ask you more question? Hello? More question for you. Okay, now, if I apply the input value of N2, N1, N0 with, for example, 1, 1, 1. 1, 1, 1, 1. Could you tell me the output based on this equation? The output is N3 is 1, N2 is 1, N1 is 1, N0 is 1. When I apply this value into this equation, the result is Why? Why 1? N3 is 1, right? Then 1 prime at here, right? And 0 plus, not 0, and 1, sorry, plus 1 prime and 1, right? The result is what? Tell me please. Why 2? It's 0, right? Okay? Okay? Okay. Actually, 1, 1, 1, 1 is this cell, right? This cell you not select. So the result is 0. Okay? For example, for this don't care. The corresponding input is 1, 0, 1, 1. If you apply 1, 0, 1, 1 in this term, it will give what? Sorry. 1, 0, 1, 1. N3 is 1, N2, 0, okay, 1, 1. From at here. Then it becomes what? 0 or 1? This term 0, right? This term is 1, right? All together become 1. So this cell you select, right? So it gives logic 1 output, okay, for the cell that you select. And it will give 0 for the cell that you not select. Okay? Everyone okay? This point is very important. Okay? Okay. Now you know don't care. And the next one. Lanshida. You? Okay. Now, Lanshida, you know well everything I said, right? Okay, you know, right? You said no. Okay. Okay, now the last topic of this chapter is this one. Multiple output. In practical, for example, in this case, 7 segment. There are this segment is LED. There are 7 LED. That means the circuit, the digital circuit, should have 7 output connect to each segment of this. Okay, multiple output. How to design? Actually, for multiple output, you can find out equation easily. You just consider each output. One output, you will get one equation. If there are 8 output, so you find 8 equation. If there are 6 output, you just find 6 equation for each output. Okay, consider one by one. For example, this function, this circuit have 2 output, output F and output G. And there are 1, 2, 3 input from X, Y, and Z. Okay? For multiple output, you just consider each output. For example, F is function of X, Y, Z for maybe this Kmap. You just find equation for each one. And for output G, you just find equation for G. Okay? Separate. Okay, separate thinking for each output. So then that's all. Okay, you get equation for output F, you get equation for output G, and then you draw the circuit diagram. Anyway, in this case or some case, note for output F there is X and Y term. For output G equation also have X and Y term. So you need not to use two AND gate. Actually, you can use only one. Something like this. Okay? Because this point, the signal value is X and Y. So you can connect this input of AND gate directly to this point. Okay? Then you can save one logic gate. Understand? Anyway, basically you separate, okay, to think, to find out equation for each output. That's all. And this one example indicates there are three outputs. Okay, so you just find equation for each one separately. Okay. This example I show you when I consider logic 1 output and when I consider logic 0 output, and I find out which one is better than the select that. Okay, that's all for this chapter. Okay? Okay.